Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. A quick note on what this video is about. Vice is an emulator for Commodore 8-bit computers, from the first PETs through to the Commodore 128 and everything in between. When first experimenting with Vice, I found that I was having trouble typing on my MacBook. After getting frustrated, I set out to make a keyboard mapping that would let me type efficiently on the emulated computers without having to significantly retrain my fingers. To be fair, the default Vice mapping worked fine for most typing, but when it came to graphical and other odd Commodore-specific characters, it became a hunting expedition, and sometimes I couldn't find the right key at all. I wanted something better. Technically, this is part 7 in a series that started with making a plan, and then went through a long and involved process to learn how to make that mapping and find what did and didn't work. In the end, I got what I wanted, and enough understanding that I think I can create almost any mapping I might need in the future. In this video, I will summarize how you can do this as well. Of course, in order to copy the file, you are going to have to find out where it is. You should be able to do this by checking your preferences. Under Input Devices is Keyboard, and there are choices for the type of mapping, positional, or symbolic, or custom files. You should be able to click the File Viewer option for the custom files, and that file selection window should tell you where the file is stored. Note that each emulator variant has its own files, so be sure you are in the folder appropriate to the emulated machine you want, be it a PET or a Commodore 64. The most likely file you want to copy is the gtk3_sim.vkm file. There is one of these for every emulated machine, though you may find that some simply include another VKM file in that folder, and in those cases, it is that included VKM that you want to copy. Each VKM file is going to have a long header block of comments. Comments start with number signs, then a short set of directive lines starting with exclamation points. You need to make sure these lines remain unchanged and are not deleted in your copy. Eventually, you'll come to the actual mapping lines themselves. If you want to make small changes, you can edit these lines directly. If you plan on making an entirely new map, then it might be better to delete these lines and then methodically recreate them, as I did for my map. Each mapping line has 4 parts: a key code, a row and column, and a shift flags value. The key code is a name for the key on the host computer. In my case, that would be my MacBook. The name of the key, however, is not always obvious, perhaps even when it seems like it is. This is where the keyboard debugger comes in. Back in the keyboard preferences, there is an option to enable keyboard debugging on the status bar. Now, when you are in Vice, every key you press is going to show up in the keyboard debugger. So if I press the minus key, we see minus in the debugger. If I press the letter Q, we see Q. Notice that it is lowercase. That is important. Key codes are case sensitive. And you can see why if I press Shift and Q together. See that the keyboard debugger is showing Shift_L for the Shift key press, and also a capital Q. When it comes to key codes, a capital Q is not the same as a lowercase q, and even though the debugger shows that the left Shift key is pressed, the capital Q key code already implies that Shift is pressed. So in the VKM file, a map to capital Q means Shift and Q together. Sometimes the key code is obvious, like if I do Shift-2 to get an @ symbol, nicely named @. But Shift-1, the exclamation point, has a key code of exclam. It isn't only Shift that can create different key codes. On the Mac, the Option key will create new key codes, like Option 3, which is a British # with a key code of sterling. As with Shift, even though the keyboard debugger shows Alt_L, which is the key code for the left Option key, the key code name sterling implies the Option key is pressed. This isn't always the case, though. If I press the Return key, I get a key code of return with a capital R. If I press Shift and Return at the same time, the debugger shows the Shift_L and Return key codes. This time, the Shift isn't generating a new key code. In cases like this, you'll need to handle things a little differently, and we'll get to that shortly. Finally, you should know that some keys are unmappable. One example of this is the max function key, or FN, which even though I am pressing, it doesn't show up on the keyboard debugger. However, other keys are modified by the Fn key. So if I press the dim screen or F1 key when the Fn key is pressed, the keyboard debugger shows F1. And a warning, some of the Option key combinations on the Mac produce an unmappable code, like Option W, which shows a code of U plus 2211. But as far as I can tell, there is no way to map this. Now we need to understand where the row and column come from. In each VKM file, there is a keyboard matrix. This matrix is different for each type of emulated machine, which is one reason why it is important to copy your VKM file from the right place. Almost every key on the emulated, in this case Commodore 64's, keyboard is in the matrix. So you find the key you want to map to, let's say B, which is row 3 and column 4. I did say almost every key. A few keys are handled specially. These use a negative row value, like the restore key, which uses a row of -3 and a column of 0. Finally, we need to understand how to assign shift flags for each mapping. The VKM documents these as well, though somewhat confusingly. These flags are used to handle all the special cases needed when it comes to adding or removing keys like Shift or Option on the host keyboard, or Shift and Commodore on the emulated Commodore computer. These combine together as needed. From the experience I've gained, I can offer this flowchart. For common keys, that is ones that aren't modifying other keys like Shift or Option, we can follow this, starting with a shift flag's value of 0. The first step is to check whether there will be more than one mapping for this key. For example, the key might be mapped for a regular key press, but have an additional mapping when combined with Control. If there is going to be another mapping to come later in the file, add 32. And from my experience, it is important to map the simplest thing first. In order, this should be the unmodified key, then the shifted key, if any, then any further key combinations. I don't know why this is. Next, we look at the key or keys being pressed on the host keyboard, again, the MacBook for me. If the host key can be both unmodified and shifted, and will map to the same emulated key, either unmodified or shifted, then add 8, and in this case, no other shift flag values should be added. This is a little tricky. Think of the case we looked at where the return key had the same key code whether the shift was pressed or not. If you plan to map return to return and shift return to shift return, then this is the flag to use. Otherwise, if the key is being pressed alone, do nothing. If the key is combined with the shift key, add 128. Note that this is not commonly used since most keys have a different key code when shifted. If the key is combined with the Alt key or Option key on the Mac, add 512. Remember, these can be combined, so mapping of a key combined with both Alt and Shift would add both 128 and 512, or 640. If the key is combined with the Control key, add 1024. That's all our options on the host side of things. Finally, we look at what's going to happen with the key on the emulator. Remember that the emulated key is determined not by the key code, but by the row and column from the keyboard matrix. If the emulated key is not shifted, but the host key is, add 16. This means that if you mapped Shift2, or the @ symbol, to the unmodified @ key on the emulator, you need this flag added in to de-shift the key. It is important to remember that for many key codes, the shift key is implied. In our example, the key code is @. You just have to know that means the shift key is pressed on the host. If the emulated key is unmodified, do nothing. If the emulated key is shifted, add 1. If the emulated key is combined with the Commodore key, add 2048. One thing to be careful of is if you combine this flag with either 1, or shifted on the emulator, 8, carry shift over from the host, or map to a shifted key on the host, you can cause the Commodore to change the character sets from its normal uppercase graphics set to upper lowercase. You may need to add in the de-shift flag of 16 to fix this. If the emulated key is combined with the Control key, add 4096. And that should handle most cases. Another use of the shift flag's value is to tell VICE about certain special keys. These flag values are 2 if the key is the left shift key, 4 if the key is the right shift key, 64 if the key is the shift lock key, which is typically mapped to the row and column of the left shift key, but also has this flag. Use flag 8192 if the key mapped to is the Commodore key. And finally use 16384 as the shift flag's value when mapping to the Control key. And that's pretty much everything you need to know to create or edit your own mappings. If you're going to create a full map, I would recommend going in with a plan. You can check out my planning phase in the first episode of the series. Here is what my final mapping to use Vice on a MacBook looks like. It should also work fine for the Mac if you ignore keys outside the core keyboard. The VKM file for this mapping is available to download. The link is in the description. Let's take a quick tour. If you want to understand better why the mapping is the way it is, there are 6 prior episodes to watch if you wish. We'll start with the top row on the MacBook. This is mostly mapping function keys and a few extra keys from the Commodore 64 keyboard. Note the special negative row mapping for the restore key. The second row is numbers and some symbols. Due to differences in the number of keys and what is on them, some of the graphic characters have been shuffled around. The Mac's third row is mostly letters with some symbols. Same with the fourth row. And the fifth row, with the bottom row being mostly those keys that modify the other keys. Note that although the Mac's control key acts like the Commodore key, it doesn't actually register as that key on the Commodore 64. If you need to actually send the Commodore key press itself to Vice, use the left command key. That leaves the Option key acting as control, both of them in fact, then the spacebar, and the cursor keys. That's my mapping. I find it works very well, for me at least. I can type almost as fast in Vice as I can normally on my MacBook. In fact, the only reason I say almost is because Vice can lag a little, so sometimes I can outtype the emulator. But that's honestly a good problem to have. I hope you got something useful out of this, and I hope you'll join me when I come back to the VKM series, because we still need to look at how to take my plan and what's been learned and apply it to build map files for all the other emulated Commodore computers. And, small teaser, that will mean dealing with some pretty wild keyboards.